So let's talk about the minimum size of the mirror required to obtain a full image of a person. Okay, so now suppose I have a person like this. This is a one-dimensional line. Assume it is a person. Now let's take this point as a head, H, this point as a eye, E, and this point as a foot, F. Okay, note that the names are chosen, the alphabets are chosen such that it is easy to remember that H stands for head, E stands for eye, and F stands for foot. Okay, now if this is a person and if I have the distance between head and the eyes as X and the distance between the eyes and the foot as Y, then the height of that person will be given by simply X plus Y. Okay, so this will be the height of the person, X plus Y. Okay, so let's remember this, we will use it later. Now if I have a mirror like this, okay, which is of the size of that person itself, then obviously that person can see his or her whole image. Okay, but imagine a light ray starts from the foot like this and is incident on the mirror like this. Okay, then upon reflection it goes into the eye. So then that person can see the foot of his or hers even without having this part of the mirror, right? Even if this part of the mirror is not there, the person can see his feet. Okay, obviously if he can see his feet, then he can see all the region between the eyes and the feet. Okay, so now same thing happens for the head part. Okay, if the head part is emitting a light ray like this, then upon reflection it will go into the eyes. Okay, and these 2 points of incidence I have named as A and B. Now this part of the mirror is not at all useful, and even this part of the mirror is not at all useful. So whatever we need is this distance between the A and B, that is the size of the mirror. Okay, we have to find out the distance between the points A and point B. Okay, so now let's do some construction. Let's draw up a perpendicular from point A on the person like this. So the AM is a perpendicular, so this is 90-degree angles, these are. Okay, now what about these two angles, angle HAM and angle EAM? So if you look at it, okay, let me draw the perpendicular from B to N also. Okay, so let's see that angle HAM is alpha. Then angle MAE must also be alpha because the laws of reflections are true, right? So similarly, if this is angle beta, then this angle is also beta, again because of the law of reflection. Now look at this. The triangle AMH and triangle AME are congruent triangles. Why they are congruent? So let's look at this triangle AMH first. You can see that the triangle, the angle HAM is alpha and angle EAM is also alpha. So we have these two angles as same for both the triangles. And then this side, the side AM is common side for both the triangles, and again this angle is same for both the triangles, that is angle AMH and angle AME. So using this ASA rule, we can say that these two triangles are congruent triangles. Okay, and similar logic follows for these two triangles, triangle BNE and triangle BNF. Okay, now since they are congruent triangles, then MH and ME must be same. Let's say they are Z, MH and ME is equal to Z. Now look at HE. HE, we have already seen that HE is equal to MH plus ME. You can look here, okay, it is MH plus ME, and since MH and ME are same, which is equal to Z, then we will write this as 2Z. But HE is equal to X, we have already seen that HE is equal to X, so X is equal to 2Z, and hence Z is equal to X by 2. Okay, now let's look at this another triangle, triangle BNE and triangle BNF. In these two triangles, both the triangles must be congruent using the same logic that we followed for these two triangles AMH and AME. Now NE and NF are same. Okay, let's assume they are equal to W. Now EF, you can see here EF is equal to EN plus NF. So EN plus NF is 2W because both are same. EN and FN are both same, right, from here, and they are equal to W. So now EN is equal to Y, which we have already seen. Oh sorry, no, it's not EN, it is EF. It should be EF. Okay, this is wrong, it should be EF. EF is equal to Y, which is 2W, and hence from this you can see that W is Y by 2. Okay, now let's look at this. ME is X by 2 and EN is Y by 2. Okay, so this EF is equal to Y and this is 2W. Okay, so now then we can look here and see that ME is X by 2 and EN is Y by 2. Okay, because EF is what? 2 times EN. EF is what? 2 times EN, that is W. W is EN, right? So now ME is X by 2 and EN is Y by 2. Now what is the distance MN? MN is ME plus EN. You can see it here. And MN is nothing but is equal to AB. Now MN is equal to AB, and which is equal to X plus Y by 2. So ME is X by 2, EN is Y by 2. So adding both of them you will get this. So AB is X plus Y by 2. But X plus Y we already have seen that it is the height of that person. So we can say that AB is height divided by 2. So AB is actually the mirror size required to see the full image of that person, right? So the size of the mirror required to see the full image of the person is nothing but the height of that person divided by the 2. Okay, so half the height. Suppose I am 180 centimeter tall, then the mirror size should be 90 centimeter at least to see my full image. Okay,